Hello students, this session is for class 12. Today's topic calculus and differentiation. Today's topic in calculus differentiation. Differentiation already we have started in class 11. So I am not going to discuss what is differentiation, from where we get the differentiation, what is limit, and this all I am not going to explain. I am not going to explain all these things again. So we will just continue the extended part, okay, from which is in class 12. Okay. Derivatives of implicit functions. Before knowing that what is implicit functions, before knowing that we have to know about the explicit function. What is the explicit functions? If y is equal to ax square plus bx plus c, in class 11 already we have done this type of function. Y is equal to ax square plus bx plus c, where y is dependent variable and x is independent variable. Why this is independent variable? Because we can choose any value of x, and when we will get any value of x, then we will obviously get different values of y depending on different values of x. Okay, that is why x is independent and y is dependent. So this is known as implicit function. This is known as explicit functions, where y independent variable always to be written to the left hand side, and independent variable, that function, that polynomial part, should be written to the right hand side. Now what is implicit function? Fxy is equal to 0. That means when x and y, both the variables are written together, that is why the fxy equals to 0, where x is dependent variable and y is independent variable. So this is one equation, x square plus y square plus 2xy equals to 4. If y is differentiable function of x, then fxy equals to 0 is differentiated with respect to x, that is dy dx is obtained. From this equation we can find dy dx directly, and that is the derivative from the implicit functions. So now we can differ about the explicit functions and the implicit function. What is the difference? Here y is written alone here to the left hand side, that is dependent variable, and here x is written to the right hand side, which is independent variable, is written in the polynomial form. Okay, and implicit functions, when x and y, both the variables dependent and independent variable written together, that is x square plus y square plus 2x equals to 4. Any kind of function we can write, any kind of polynomial we can write here. Next is derivative of parametric equations. What is parameter here? Parameter is t. X is equal to ft and y is equal to gt, where ft and gt are both differentiable with respect to t. If inverse function of x is equal to ft is t equals to phi x, then from y equals to gt, where t is equal to phi x, then y is a function of x. Just see, x is equal to ft, y is equal to gt, where ft and gt are both differentiable with respect to t. If inverse function of x is equal to ft, that is t is equal to phi x, then from y is equal to gt, where t is equal to phi x, that means now y is a function of x. Where t is phi x, then y is equal to g of phi x. So y is a function of x. So dy dx is equal to dy dt into dt dx. Okay, so in this way we can find the derivative of any kind of parametric equation. Here parameter is t. We can find the parameter as theta also, parameter as alpha also, parameter as beta also. Any kind of parameter we can get. Here the parameter is t. Next is derivative of inverse circular function. Y is equal to sine inverse x. Inverse circular function, y is equal to sine inverse x, cos inverse x, tan inverse x. All these are inverse functions. All these are inverse functions. So y is equal to sine inverse x, where x is equal to sine y. So dx dy is equal to cos y. So dx dy equal to 0. When dx dy will be 0? When y is equal to plus minus 2. Plus minus 2 means y is 90 degree. So we know as cos pi by 2 equals to sin 0, 0, cos 90, 0. So cos pi by 2 equals to 0. When cos pi by 2 equals to 0, therefore we can write dx dy equals to 0. So dy dx means 1 by dx dy. Dy dx means 1 by dx dy. 1 by dx dy means 1 by cos y. 1 by cos y is equal to 1 by square root of 1 minus sin square y. Cos y equals to square root of 1 minus sin square y. So 1 minus square root of sin y equals to, we know sin y equals to x. So 1 by square root of 1 minus x square. Therefore d dx of sin inverse x is equals to, we get square root 1 by square root of 1 minus x square, where modulus x less than 1. Obviously mod x less than 1. Otherwise, if it is not less than 1, then the denominator part will be 0. If the denominator part will be 0, then it will be undefined. That is why the restriction is very, very important. Now, next is ddx of, similarly, we can find the value of ddx of derivative of cos inverse x. Derivative of cos inverse x minus 1 by square root of 1 minus x square. This part you can find on your own. Now, next is derivative of cot inverse x. How to find the derivative of cot inverse x? Different methods are there. I am showing you one method. In book you will get another method. I explained in PDF file also you will get the second method also. Now let y equals to cot inverse x, x is equal to cot y. So dx dy will be ddx of cot x, we know, minus cosec square x. So it is coming minus cosec square y. Dy dx is minus 1 by cosec square y. Since it is dx dy equals to minus cosec square y, so dy dx will be minus 1 by cosec square y. So minus 1 by cosec square y means, we know, cosec square theta means 1 plus cot square theta. So it's coming 1 by 1 plus cot square y. Minus 1 by cot y is equal to x here. So minus 1 by 1 plus x square. This is equals to derivative of cot inverse x. Next, similarly, we can find the derivative of sec inverse x, derivative of cosec inverse x. Next is logarithmic function, logarithmic differentiation. How to find the logarithmic differentiation? Logarithmic differentiation. To differentiate say y is equal to u to the power v and y is equal to f1x into f2x into say fnx. If the functions are in this way, y is equal to y to the power v, where both y and v, where both u and v, where both u and v are functions of x, both functions of x, okay, or another function is y is equal to the product form. So one is the power form, another is the product form. If we get the function in this way, then only we have to apply this logarithmic difference, logarithmic form. What is the logarithmic form? We have to take logarithmic to the both side, taking logarithm to the both side. Then what we will get? By taking logarithm to both the sides, what we will get? From here we can write log y is equal to log u to the power v. So we can write log a to the power n is m log a. Same formula we will use here. So v log u. So it is coming log y is equal to v log u. Okay. Similarly, and then we have to just differentiating both the sides, then we will get dy dx. Similarly, here also we will apply the same thing. Log y is equals to log of the product. What is the product form here? f1x into f2x into fnx. Up to this. So log mn. What is the formula? Log mn means log m plus log n. So we can expand this part as log f1x plus log f2x plus to log fnx. Then again we will do the same thing, differentiating both sides with respect to x. We can find the derivative of this logarithmic function. Okay, next is function of a function. Function of a function. How to find the derivative of a function of a function? Say u is equal to derivative for function of a function. Derivative of a function of function. How to find it? Say u is equal to phi x. U is equal to phi x in the interval a less equal to x less equals to b. This is the closed interval that we know. A less equal to x less equal to b means this is the closed interval. And another function y is equal to function of u, okay, where c less equals to u less equals to d. This is also closed. As it is given less equal to, so this is known as closed interval. Okay, so y is differentiable in this and u is equal to phi x is differentiable in this interval. Okay, then we can express the function as y is equal to function of phi x. Can we write it? Because u equals to phi x and y equals to f u. So we can write y equals to f of phi x, y equals to f of phi x with respect to x. With respect to x, therefore dy dx is equals to f dash du into phi dash x. Okay, the f dash du means dy du into, this is phi dash x means du dx. Okay, so dy dx is dy du into du dx. Okay, next, derivative of one function with respect to another function. Derivative of one function with respect to another function. Derivative of one function with respect to another function. How to do it? That means if I write, say, there are two functions. One is ux, another is vx. We are to derivative of function ux with respect to vx. How to do it? Let y is equal to ux and let z is equal to vx. Since we are to find the derivative of ux with respect to vx and we have taken y is equal to ux and z is equal to vx, there that means we have to find actually dy dz. We have to find actually dy dz. So what we will write? Dy dz means we can write dy dz is dy dx into dx dz. How to find it? From here we can find dy dx. Find it, this is coming u dash x, and from here we can find dz dx. That is equals to v dash x. Okay, now put the value here. Then what we will get? Dy dz will be u dash x by v dash x. Dx dz equal, to find the value of dx dx is v dash x, so dx dz 1 by v dash x. So that is why dy dz will be u dash x by v dash x. Okay. Now we'll start the exercise, coming with the next session with the exercise.